Students, in this video we are going to discuss about ray optics. Well, ray optics is that branch of physics which deals with all those phenomena of light that can be explained by considering that light travels in the form of straight lines, straight rays. We know what is reflection of light. Basically, when a light ray strikes a smooth, well-polished surface and then it bounces back, then this event is known as reflection of light. And now, in this video, we are going to understand about refraction of light. I'll give you few instances where you will observe this spectacular phenomena. Do you know that when a pencil is half immersed in a glass of water, then the pencil appears to be broken? Do you know why this happens? Well, there is another one too. When a coin is dropped in a glass full of water and you try to see that coin, when a coin is dropped in a glass full of water like this and you try to observe that coin from the top of the glass, then the coin appears to be raised. Do you know why this happens? These two spectacular illusions are nothing but refraction of light. Whenever light goes from one transparent medium to another, then the path of the light ray gets changed, and this event is known as refraction of light. You can see here light is coming from one transparent medium and it strikes here, and a part of it is reflected back and another part tends to move further and it crosses to go to the second medium. So this is known as refracted ray, and the phenomena of going from one transparent medium to the other transparent medium is known as refraction of light. And the observations that I was telling you about, those two observations are nothing but refraction of light. Now we will be discussing about laws of refraction of light. Whenever light goes from one medium to the another medium, the frequency of light does not change, phase of light does not change, but the velocity and wavelength of light change. Okay? Law number 2, incident ray, refracted ray and normal, they all lie in the same plane. To law number 1, if you want me to explain these terms, see, frequency of light means number of light rays crossing a point in 1 second. That's frequency. So when light ray goes from one medium to another medium, this frequency does not change. Phase also does not change. Phase means the state of light. If you consider light to be a wave, it goes like this, right? So the wave is starting from this point. So this is phase. So had it been starting from here, like this, so the phase difference between this wave and this wave is 90 degree, right? Because it's starting from here, like this, and this is starting from 0 point. Okay? And next is incident ray, refracted ray and normal. They all lie in the same plane. And the third law is Snell's law. This says that when light ray goes from one medium to another medium, then the angle made by the ray, I repeat, see, this is the interface. This is the interface separating two media. Okay, light ray is incident like this. So it is making an angle with the normal, that is angle of incidence. And when it gets refracted, this changes its path. It does not go by the same path. And this is angle R. Now Snell's law says that refractive index of one medium multiplied by sine of angle made in that medium is constant. So mu sine I is constant, and we know that this is medium 1 from where the light is coming, and this is medium 2 to where the light is going. Angle made in medium 1 is I and angle made in medium 2 is R. So mu 1 sine I equals to mu 2 sine R. The product will be constant whether it is 5 into 4 equals to 20 or 10 into 2 is equal to 20. But the product is going to be constant, right? And mu 1 is the refractive index of medium 1 and mu 2 is the refractive index of medium 2. So this law is Snell's law. But here I have used the term without even introducing you all with that, and that term is refractive index. What is refractive index? See, always remember that whenever light ray goes from one medium to another medium, it changes its path. But the question is why it changes its path? Why does it change its direction? The answer to that question lies in the fact that actually when light ray goes from one medium to another medium, then its velocity changes, its speed changes. And when the speed of the light changes, then this speed can increase in going from one medium to another medium, or this speed can decrease in going from one medium to another medium. So if the light is going from one medium to another medium and its speed is increasing, then we would say that this medium to which light has gone, that medium is rarer medium, and the medium from which it has come was denser medium. Similarly, when light goes from this medium to this medium and its speed decreases, then we would say that light has entered into a denser medium and it came from a rarer medium. Okay, so refractive index tells us about this only. Refractive index tells us whether the light has increased its speed when it has gone from one medium to another, or it has decreased its speed in going from one medium to another medium. Okay, so let's try to understand what do we mean by refractive index. Refractive index can be categorized into two parts: absolute refractive index and relative refractive index. Absolute refractive index will compare the velocity of one medium to the velocity of light in vacuum. I repeat, absolute refractive index will compare the velocity of light in one medium with the velocity of light in vacuum. Relative refractive index will compare the velocity of light in two different media. So, absolute refractive index is represented by mu. It's a ratio of speed of light in vacuum or air divided by speed of light in medium. Speed of light in vacuum is represented by C and speed of light in medium is represented by V. Value of refractive index depends upon nature of material of the medium and wavelength of light. Now talking about relative refractive index, when light goes from one medium to another medium and these two media are different, none of them is vacuum or air. जैसे डायमंड से वाटर में गई है लाइट. Okay, so we are talking about two different media, right? So if you want to know the refractive index of one medium with respect to the other medium, it is written as mu2 by mu1. Like refractive index of medium 2 with respect to medium 1. Now mu2 is the absolute refractive index and it can be written as vacuum के अंदर light की speed divided by medium के अंदर light की speed. Mu1 can be written as C by V1. When you will take out the ratio, this will become V1 by V2. So speed of light in medium 1 divided by speed of light in medium 2. Okay, so Remember, I'll tell you few points. Refractive index is the measure of optical density of any medium. Refractive index will tell us whether the light will decrease its speed when it goes from one particular medium to another, or will it increase its speed when it goes from one particular medium to another. And it is just a mathematical ratio, refractive index. There are two ways by which we can study refractive index. One is absolute refractive index, the other is relative refractive index. Absolute refractive index compares the speed of light in one medium with the speed of light in vacuum. Okay, and relative refractive index compares the speeds of light in two different media. It could be glass and air, it could be water and diamond. So two different media other than vacuum, right? So remember, when you have higher refractive index of a medium, so that means the medium is very, very optically denser, which means speed of light decreases so much in that medium. देखो, अगर refractive index की वैल्यू ज्यादा आती है तो न्यूमरेटर ज्यादा है और डिनोमिनेटर कम है. डिनोमिनेटर इज स्पीड ऑफ लाइट इन मीडियम, यानी उस मीडियम में डिक्रीज हो जाती है लाइट की स्पीड बहुत ज्यादा. तो वो बहुत ज्यादा ऑप्टिकली डेंसर मीडियम है कि लाइट इतना फास्टर चली आ रही थी, बट एज सुन एज इट एंटर्ड द मीडियम its speed got decreased drastically. Okay, similarly अगर lower refractive index की वैल्यू आ रही है, जिसका मतलब जो है जो डिनोमिनेटर है उसकी वैल्यू ज्यादा तभी कम आ रही है, lower refractive index, but denominator is speed of light in medium. So this means this is greater. So this means when light actually goes to optically rarer medium, its speed boosts up. Okay, its speed increases. Okay, next is cause of refraction of light. I have already told you that refraction happens because of the reason that when light goes from one medium to another medium, its speed gets changed, and this is the cause of refraction, and this is why the path of light ray gets changed. Okay, so let's try to analyze what will happen with the light ray when it goes from rarer to denser medium, and what will happen with it when it goes from denser to rarer. Suppose light is coming from a rarer medium and it is going to a denser medium. Okay, so this is the interface which is separating two media. This is the line of normal, and this is incident light ray. The angle which incident light ray makes with the normal is angle of incidence, and then it deviates, and this is angle R. Okay, so refractive index of medium 1, let us name it as medium 1 from where the light is coming, and let us name it as medium 2 to where the light is going. So I will be using subscripts 1 for this medium, okay, jahan se light aa rahi hai, and I will use the subscripts 2 for this medium to where the light is going. If I'll apply Snell's law here, this will be mu1 sin I equals to mu2 sin R. Very simple. Now mu1 upon mu2 equals to sin R upon sin I. Right? So we know that this is a rarer medium and this is a denser medium. So its refractive index will be lower than the refractive index of this medium, which is denser medium. So mu1 is less than mu2. So if mu1 is less than mu2, can you write it mu1 less than mu2 into 1? Can you write it mu1, take this to the another side, it will become upon mu2 less than 1. So mu1 by mu2 is coming out less than 1. If mu1 by mu2 is coming out less than 1, this is equal to this stuff. So this will also come out, sin r upon sin I will also be less than 1 because they both are equal. Okay, if this is 3 by 2, this is also 3 by 2. तो ये अगर ये less than 1 है, so this will also be less than 1. So sin r is less than sin I. So r is less than I. यानी एंगल ऑफ रिफ्रैक्शन जो है ना, जो कि रिफ्रैक्टेड रे नॉर्मल के साथ बनाती है, उसका वैल्यू कम है एज कंपेयर टू एंगल ऑफ इंसिडेंट्स विच इंसिडेंट रे मेक्स विद द नॉर्मल. ओके, सो दिस मीन्स अगर ये वाला एंगल कम है तो आपको ऐसा अपीयर होगा कि जो रिफ्रैक्टेड रे है ना, वो नॉर्मल की तरफ बेंड कर गई है. सो दिस इज द सिचुएशन व्हेन लाइट रे विल बेंड टुवर्ड्स द नॉर्मल. So the question is, prove that when light ray goes from rarer to denser medium, then it bends towards the normal. Okay, I have proved it, right? Same way you have another derivation for this too, which is, suppose light ray comes from denser medium. This is the interface separating two media. This is denser medium, right? And then you have rarer medium. This is denser medium, this is rarer medium. Now, this is normal, right? And suppose this is the light ray. This is angle I and this is angle R. Now, the light is coming from this medium, denser medium, and it is going to rarer medium. I will now name this as medium 1 and I will name this as medium 2, जहाँ से light आ रही है and where it is going. So if I'll apply Snell's law here, that will be mu1 sin I equals to mu2 sin R. Fine. Mu1 by mu2 equals to sin R by sin I. Always remember from where the light is coming is named as medium 1 always, and to where the light is going is named as medium 2 always. So medium 1 is denser and medium 2 is rarer. So denser medium has refractive index greater as compared to rarer medium. So mu1 is greater than mu2. Mu1 is greater than mu2. Fine. So mu1, can you write it? Mu2 into 1. This is one and the same thing. Take this mu2 to this side. Mu1 upon mu2 is greater than 1. So this stuff is greater than 1. So this means sin R upon sin I, this is also greater than 1. So sin R is greater than sin I. So R is greater than I. So R is the angle which the refracted ray makes with the normal and I is the angle which the incident ray makes with the normal. So इसका मतलब ये हुआ कि जब लाइट रे डेंसर से रेयर मीडियम में जाती है तो एंगल ऑफ रिफ्रैक्शन बहुत ज्यादा होता है, जिससे ये अपीयर होता है कि ये अवे फ्रॉम द नॉर्मल बेंड किया है. सो दिस इज द प्रूफ दैट व्हेन लाइट रे गोज फ्रॉम डेंसर to rarer medium, it always bends away from the light, away from the normal.